Article 625 of the National Electric Code, NEC, sets forth installation safety requirements for typical hardwired connections of plug-in electric vehicle battery charging equipment. In particular, Article 625 covers the wiring methods, equipment construction, control and protection, and equipment locations for electric vehicle charging equipment. Throughout Article 625, the intent is to prevent users of electrical equipment associated with the vehicle charging system from being exposed to energized live parts and to provide for a safe vehicle charging environment. It's important to note that electrical contractors installing EVSE equipment for home recharging of electric drive vehicles install according to NEC Article 625.
But it all starts in chapters 1 through 4, your general requirements in the NEC. And the reason I say that is because in Chapter 1, for example, you have your requirements that deal with listed equipment and installing listed equipment in accordance with its installation instructions. Chapter 2, you have your overcurrent protection requirements for branch circuits. You have your grounding and bonding requirements for installations. In Chapter 3, you have your conductor sizes in Article 310, and you have your wiring methods covered in Chapter 3. And all of those are inherent components for installing a branch circuit to service equipment or a panel board that's going to supply electric vehicle supply equipment. And then what you have in Article 625 is the specific requirements for that type of equipment.
Some of the key tenets of Article 625 include 625.5. All electrical materials, devices, fittings, and associated equipment are required to be listed or labeled. 625.13. Electric vehicle supply equipment rated at 125 volts, 15 or 20 amps, and listed as suitable for the purpose shall be permitted to be cord and plug connected. All other electric vehicle supply equipment shall be permanently connected and fastened in place. It's important to note that 240 volt, 40 to 80 amp EVSE can be cord and plug connected as long as the EVSE meets the requirements of 625.18, 625.19, and 625.29. 625.18. The EVSE shall provide an interlock that de-energizes the electric vehicle connector and its cable when the electrical connector is uncoupled from the electric vehicle. 625.19. The EVSE, or cable connector combination of the equipment, shall be provided with an automatic means to de-energize the cable conductors and electric vehicle connector upon exposure to strain that could result in either cable rupture or separation of the cable from the electric connector and exposure of live parts.
The Level 1 and Level 2 could be cord and plug connected. Level 1 typically is cord and plug connected. But Level 2, you have the option, and it's all related to how the Level 2 is listed and evaluated and identified for use. If it's listed and identified for use in a cord and plug connected application or arrangement, it would be suitable for use, and the authority having jurisdiction would verify that through the installation instructions and the nameplate information on that equipment.
625.21. Overcurrent protection for feeders and branch circuits supplying electric vehicle supply equipment shall be sized for continuous duty and shall have a rating of not less than 125% of the maximum load of the EVSE.
If you have a continuous duty load, which is inherent to EVSE, a continuous duty load being one that is in place or on for 3 hours or more, it's required not to exceed 80% of the branch circuit rating.
625.22. The EVSE shall have a system of protection against electric shock. Standard ground fault circuit interruption equipment, or GFCI, does not provide the range of protection needed for the various types of charging systems. 625.23. For electric vehicle supply equipment rated at more than 60 amps or more than 150 volts to ground, a disconnecting means shall be provided and installed in a readily accessible location. The NFPA NEC technical committees are currently working on clarifying NEC requirements for electric vehicle supply equipment, such as individual branch circuit requirements and equipment that is permitted to be cord and plug connected. This is to ensure that effective application of essential code and safety requirements can be applied to all EVSE installations. In addition, it's important to note that local conditions may require amendments to the National Electrical Code. Finally, the National Electrical Contractors Association has developed a National Electrical Installation Standard, NEIS, for installing and maintaining electric vehicle supply equipment. NEIS 413 addresses all safety concerns in addition to important performance and quality aspects of the installation.
The National Electrical Code is set up for adoption by any local jurisdiction, be it at the state level, municipality level, county level, town level, city level, and they usually will adopt the National Electrical Code into law, meaning that that's the law and one must do at least that much. Often in particular jurisdictions there may be conditions that may be unique to that area, such as high heat applications, problems with corrosion in the soil because it has a high alkalinity content. Those are specific things that are unique to that area that may cause a need for specific amendments to the National Electrical Code. But the National Electrical Code really is the minimum. Once adopted, one must do at least that much to ensure a safe and essentially safe electrical installation. NECA has developed a family of national electrical installation standards that are ANSI accredited. They're ANSI approved standards. That means they are fully vetted through an open consensus balloting process through industry experts. So the NEIS, if you will, complement the NEC minimum safety requirements, and they provide quality and performance aspects in a manner that is easily understandable as to what constitutes good workmanship in electrical contracting, ultimately providing customers with the highest quality electrical product from the contractor.